Probably the single most important thing for lithology in V clay is the gamma ray. Density neutron is important as well, of course, but the gamma ray is important. It's pretty simple and it's usually quite sort of reliable, and not always. Sometimes you can have feldspar or mica or something which makes it not reliable, but it's fairly reliable. And probably the most important thing that you see in that is actually a histogram, which is this one right here. Okay, so there we've got a histogram of the gamma ray, the corrected gamma ray, which is the gamma ray minus the uranium effect. That's thorium plus potassium gamma ray, along the x-axis, and the relative frequency of occurrence of these different values. So there are lots of occurrences of this parameter between about 50 and 60 in there, right? But there aren't many occurrences of it at 15. So what we do is we pick the cleanest occurrences, which are down, not the very lowest one, but sort of off because there could be some bad data or something strange could be going on there. So we pick it conventionally at about the 5 percentile value, although I use the 2 percentile. Conventionally in textbooks you'll see the 5 percentile is used for the clean or the lowest gamma ray, which by implication is the lowest amount of shale. And then the 95 percentile, which in this case is 86 for this value, for this parameter. When this parameter, corrected gamma ray, has gone to a value of 86, then we can say, well, that's a fully developed shale. And all you do is you have a simple equation, which is this one here, and you say that here are the two end members, right? Here's CGR shale, which is this one, CGR clean, which is this one, and as the parameter that you're monitoring, this one, moves between that and that, you get this equation moves between 0 and 1. So you get volume of shale from the gamma ray is equal to, between 0 and 1 as this parameter moves. You see, as that ratio moves as this overall ratio moves from 0 when that is equal to that to the shale value when that is equal to that. Okay, very, very simple. That's the basis of the way that it works. There's complications with non-linear equations, which I'm not going to go into in this 5-minute lecture, and there are lots of other ifs and buts, like it's not only clay minerals that are a valid part of shales that will give you the gamma ray. Of course, there can be other things like feldspars that can give you gamma ray, etc. So it's not the only thing we need to talk about, of course, but it's the only thing we can talk about in this 5-minute section. I will talk briefly about the other main method, which is density neutron. And density neutron, as you all know, has a negative separation in shales and generally a positive separation in sands, or particularly in gas-filled sands. So that's the other sort of parameter, the sort of lithology parameter that we use commonly in determining lithology in V shale, which I've gone into in more depth in the proper course, not in the VALT version of the course, but in the proper course the 5-day face-to-face course that hopefully one day I will run again when we get over this terrible COVID thing. Okay, I think that's pretty much enough. In the VALT, I do talk a little bit about the Thomas Steiber plot, which is, if you're a Shell fan, then would have heard all about that. I talk a little bit about that in the VALT, and also right now I should just briefly say that there are some things that when in this course and in your studies or in your work as a petrophysicist, you should, when you get to a sort of about one of the 5 or 6 stages, that sort of milestones there are in the evaluation, you need to stop before you go on to the next one. You need to kind of check it and make sure it's reasonably okay, because of course in petrophysics the next parameter is dependent upon, in part, the earlier parameter. So let's make sure the earlier parameter is good as we can get it within reason, before we move on to the next one, because if we have errors here in the first one, we're going to affect the second one, right? And the errors may well compound. So I just have a little checklist, which is the green slides, which non-petrophysicists often don't like because well, sorry, the other way around. petrophysicists often don't like because it encourages the non-petrophysicists to check the petrophysicists' work. But you as a petrophysicist should check your own work with these very simple green review slides, which I shall now show you for shaliness, which is basically this one. Always ask yourself, as a reviewer, that can include yourself as a petrophysicist, which logs are going to dominate your vshale output? If it's gamma ray, do we have non-clay mineral radioactive minerals present, like feldspar, for example? If density neutron is dominating your vshale output, then do we have gas present? Because of course gas will affect the density neutron dramatically, and it will give you a completely wrong impression of the amount of shaliness if it's gas effect, and you've got to deal with that. And of course you need to compare different values, different evaluations of vshale, gamma ray, density neutron, density sonic, and you've got to understand how they've been, why they exist, and how they've been treated in your final evaluation of your vshale or lithology. And then have you looked at all the other data? Have you looked at XRD logs? Have you looked at mineral log? Have you looked at core photographs? Have you looked at the good old mud logs, etc.? Can anything else help you to check on your output? Now, sadly, you probably will not have a proper quantitative check. It's almost impossible to get a proper quantitative check for vshale, but you can get some idea. And then, of course, very important one, what data calibrates vshale equals 0? Is it just the lowest gamma ray? Yes, it probably is. I would say in 8 out of 10 evaluations, the lowest, what's considered to be clean in inverted commas, is actually just the lowest gamma ray. Well, we don't know if it's really clean, do we? But that's the kind of assumptions that we make in log analysis all the time. And then finally, as a petrophysicist yourself, you should know if your porosity, right, which is actually going to go into reserves, if your porosity if the porosity has been affected by a change in vshale. So if you find in your evaluation that when you change vshale by, let's say, 10%, your porosity also changes by a significant amount, then really it's not nice. You know, it means that you've got something which is very uncertain, which is affecting your evaluation. So either change your evaluation method to remove or lessen the impact of this terrible thing, vshale, the impact of the uncertainty of it. I don't mean terrible in itself, I mean the uncertainty in vshale, which is big. We can design an evaluation to reduce that impact, or go back and check vshale that you can make it more credible, more robust, more accurate. That's it, folks, for that little video.